This is exercise number 4 from chapter 11, counting 1B. We're going to make a comparison here of the single plant-wide factory overhead rate and the multiple production department factory overhead rate. We've done each one separately in exercise 1 and 3. Now we're going to do the two of them combined to compare them. It says Cobalt engines manufactured gasoline and diesel engines through two production departments, fabrication and assembly. Management needs accurate product cost report information in order to guide product strategy. Presently, the company uses a single plant-wide factory overhead rate for allocating the factory overhead to the two products. However, management is considering the multiple production department factory overhead rate method. The following factory overhead was budgeted for Cobalt. Factory department factory overhead or fabrication department was $559,000. Assembly was $215,000 for a total of $774,000. The direct labor hours for fabrication $4,300, assembly $4,300 for a total of $8,600 hours. In addition, the various engines, gasoline and diesel, require a different number of hours in each department. So first, determine the factory overhead allocation to the gasoline and diesel engines under the single plant-wide rate. Let's go over here and we'll go to my tablet where I can calculate. And we'll make the calculation, and that initially is going to be the 774,000. I'm going to divide that by the 8,600. This is for the single plant-wide rate. That equals $90 per hour. So $90 per hour. And I can then, for the single plant-wide rate, multiply the $90 times the total number of hours used. So it's going to be $4 for each. So under the single plant-wide, I'd take $90 times 4, and that's $360. So I'd allocate $360 to both the gasoline and diesel. So now we can see that under the single plant-wide method, it's the same for both. But next, we're going to go to the production department method where it's allocated by both, and we'll see the differences. So if I go here, I'm going to erase the single plant-wide rate. Get that out of my way. And first, I'm going to take the fabrication, which is $559,000. I'll divide that by the number of hours of 4,300. That equals $130 per hour. Next, I'll take the assembly department of $215,000, divide it by 4,300 hours, and I have $50 per hour. Once I have those numbers, I can then multiply it based on the hours consumed in each. And for the gasoline engine, they consume 1.1 hours in the fabrication department. So I'll take the 130 times the 1.1 hours. So I'm taking this number here times my 130. is $143. I also have to calculate it based on the assembly department. That's $50, and we're using 2.9 hours. So 2.9 and $50 equals $145. So my total then for the gasoline engine is going to be $288. While we're here, let's go ahead and use the numbers to calculate for the diesel. The diesel uses the 290 at 130 and 110 at 50. So I'm going to go 2.9 at 130. Show you where I got that again. 2.9 hours in fabrication times my $130 factory overhead rate. $87. No, that's not right. Let's do that again. 130 times 2.9 is $377. Better. Okay. Now, at the $50 rate, they use 1.1 for the diesel engine. So 1.1, $50. That's $55, of course. We can add those together. Looks like $432. So we can see now if we take these two numbers and plug those in, this one was 288. And 432. Check my work. We can see that we have it correct. The key point being is that if we're looking for accuracy, a single plant-wide rate is not as accurate because it's doing even allocation under a single plant-wide under each. However, if we use a multiple production department, we are finding that they are different. And this is part of the product cost distortion theory. So I hope this helps.